Thank you, Colonel Dattowadi, for the introduction, and thank you, Smart Water and Wastewater World, for giving this opportunity to present this particular presentation with very esteemed panelists like Professor Tansel, Professor Rao, and Colonel Dattowadi. So basically, I'm going to talk more of how we can use whatever the technologies Professor Tansel has very nicely presented the technology scenario. I'll be speaking more from enabling this particular circular economy in urban water, and particularly in the context of India, what is happening in the field and how we can really leverage this opportunity of circular economy and make this particular circular economy work. So to further introduce my work, I work in these four particular areas. I call this four hats. So many people know me for water supply. People know me for wastewater management. I work in climate change mitigation and sustainability assessment. And I am core faculty at Center for Urban Science and Engineering at IIT Bombay. And we have a virtual center interdisciplinary program in climate studies, because climate is a very interdisciplinary topic and many things are there. So we have a virtual group also. So today I'm going to focus more on a wastewater story, which is a theme of this particular webinar. So specifically urban water cycle in India, if you see, we have to reach to circular urban water cycle. But currently we abstract water, we treat, we distribute, we consume, we generate wastewater and try to treat and then dispose. And there is no circularity. We are most in linear use of it. So this is our water cycle, but a lot of urbanization impacts are happening, which are like population, as Professor Tansel has highlighted, the population and other industrial uses are increasing, lifestyles are changing. So many issues are there. And changing from linear to circular is a big challenge, and we will see what are the challenges and opportunity into it. So we want to achieve this particular 6 R's. So entire presentation will be attached to this particular reduce, reclaim, recycle, restore, recover, these 6 principles of recycling. And there can be more R's also. People have listed many types of R. So particularly in India, the sewage treatment and generation scenario, if you see, every state is falling the gap. There is a gap between how much sewage is generated and installed capacity. So every city is behind installing more treatment capacity. And this is the overall in India, about 37 sewage treatment capacity is there, and rest is the gap. But we have to understand what is the important resource, but generated wastewater itself is a more important resource, and that particular change of mindset is needed. Recently this data was released again from Central Pollution Control Board. If you see, although we are saying we are in a gap of the treatment system, but if you see the capacity that is utilized, that is not fully utilized. So many locations I have found that treatment plant is there, but the collection system is not complete or not there at all, and the treatment plant is there. So we are in this particular situation where treatment plant of big capacity for the next 30 years is installed. But I think we, as a consultant or as an engineer, we understand there can be modular construction, there can be phase-wise construction, but urban local bodies wants to go for a single tender for a 30 years contract. So there are so many issues, and the entire investment of huge infrastructure is going waste. So capacity utilization has to be focused, even if with the simple analysis. And so a couple of students are going to work on further detailing on this particular capacity utilization. But that I see a big gap. Coming to the quality standards, historically we have been used this particular general discharge standard of discharge, where our typical BOD in our mindset is 30, and there has been a lot of pressure to change and modify more stringent norms. So recently there was a change. I'll come to that. But if you see, these are the desired water quality standards for recycling, for toilet flushing, landscape irrigation, and fire protection. And you can see in Mumbai, the standards are there. In High-Rise Building Committee has recommended these standards, more stringent than Western countries. Issue is enforcement. Issue is why and who will do this? That is the more important question to be asked. So it is not a question of whether we have a standard or whether we need a more debate on this. We have standard, and that is also recently given a clear order from National Green Tribunal that if your typical inlet is this sewage, the committee recommended these standards basically for mega and metropolitan cities, 10 milligram per liter BOD standard, class 1, and other there is some still flexibility. But NGT has clearly said that all are equal and all water resources are equal, and we have to go for this particular aim for this particular discharge standard. Now, this poses a big burden on the infrastructure, because how cities will generate the money and how they can basically cope up with this particular new discharge standard, because they are already running to match 30 milligram per liter sewage treatment infrastructure. Now, suddenly 10 milligram per liter is a big challenge, but it can be converted to opportunity, and that's what I'm going to discuss. These are the broad approaches of wastewater management, and Professor Tansel has already given you the overview. But this is the management side, that you first we have to work on prevention also and conservation also. That keep neglected always, and we directly jump on treatment side. But this is a big box, big opportunities there. And we have to then move from treatment to recycling to recovery, and it's a big change in the infrastructure mindset and infrastructure planners that has to be brought in. That it's not only the treatment, but we have to lead to a recovery. And then there is a building level treatment, then there is a decentralized, and there is a centralized. So this spectrum also we have to keep in mind. And there are different technologies from physicochemical to biological, aerobic to anaerobic. There are suspended growth and attached growth. Everyone, I think the people in water industry know this particular diagram. So we have the technology, we have the need. So what's wrong? Why we are not able to achieve this? That is the bigger question. So what is wrong with the current approach? So if you see, this is, let's say, physical boundary of the city. And what we are doing is we are having the agriculture land which is using artificial fertilizers to produce our food. That food gets consumed in the households. We use detergents and chemicals in the households. We fetch fresh water from a large dam, stored water hundreds of kilometers, for example, in Mumbai city. And then we generate wastewater, which is again having this NPK and organic matter as a pollutant. And then we have a centralized treatment system, which is discharging this sludge and the effluent. And these all carry all these particular nutrients and energy. So issue is that on one side, we are fixing the nitrogen at a huge amount of energy in the industry, in the fertilizer industry. And we are again putting the energy back to release this nitrogen back to the atmosphere. So you can see hello. Yeah. So you can see on one side, you have a huge investment on the energy for fixation and then release. So this needs to be fixed. We have to stop this particular use of artificial fertilizers and create the fertilizers from this sludge. And that is a huge technological change. A lot of policy changes need to be done. We have to stop consuming the fresh water as much as possible, and we have to create the secondary uses of the water that we are already fetching. So virgin water consumption has to be reduced, and we have to stop consuming the energy. We have to make our treatment system as energy neutral as possible, and we have to create the energy also from this particular system. And this will happen if we plan and change the policies as well. It's not the technology, but policy changes are also required. So this will happen only if we apply decentralized, because if you put everything at a very far end of the system, decentralization is the only solution we can achieve this. And when I say decentralization, many people get upset. People say, oh, why decentralization? Do you know what is the problem? I know, I worked in industry. I know what are the problems and issues with the technologies. So the issues here are, we will discuss in the decentralized and centralized later, but consumer awareness is another big challenge. So basically, centralized system, as we all know, it is a tail end system where everything is taken out of the city boundary or towards the end of the city and then treated. In decentralized, we try to do some scalable, small scale systems where decentralized treatment can be used. Now, the issue is this decentralization is of the scale. Too small systems difficult to operate and govern and do not offer scale of economy. So we have to do not jump on a decentralization just blindly. We have to also need to look at what is the scale of economy, how small systems are feasible. So And highly centralized systems place a challenge in recycling of treated effluent and sludge, because if you put everything at one place and try to recycle, again secondary distribution network cost will become, sludge transportation cost will come, and there is no scale of economy beyond one point. So all engineers will understand this, that this, so the scale of economy is somewhere in between. So, and this additionally requires deeper sewage network for flat terrains and difficult to maintain. So I've seen in many cities the situation of sewerage network. Enthusiastically, people go for a sewerage network underground, and then maintenance is with urban local body. It is very difficult to manage for them. So we have a spectrum from highly centralized to highly decentralized to highly centralized. The currently urban local bodies, and I would say consultants, are also very comfortable with the this particular idea of highly centralized infrastructure. They are trained, that they are basically trained to think in that manner only. And I request all of you taken, because see, it is easy to prepare DPR in one shot of a centralized system, propose everything in one go, and just go for a big budget project. That's everyone likes. Politicians, consultants, EPC contractors, everyone likes that. And that is, I see as a very big problem we have, and a lot of changes are there. Coming to decentralized, people enthusiastically put very small systems at building level, and somewhere which is not feasible. The building societies are not interested to operate these treatment plants. So who will take care? Because so we are at this one far end and another far end. The ideal zone for implementation is this in between, where this, for every city this scale will be different. So we have to identify for that given city how we can segregate the centralized system and have a decentralized system, so that the 6R, that is recycle, use, reduce, all those will be implemented. If we have that kind of flexible infrastructure, it will create a much more opportunities than a centralized infrastructure. That's the whole point I'm trying to make. So the challenges in wastewater recycling is scale of implementation is not known. People just go for a centralized, that because there is no knowledge. So we are working on that to create that knowledge. Energy requirement, can we make it energy neutral? Because there is no revenue with the urban local body to operate these plants. So much of dark situation, people put off the aerators because they cannot pay energy charges. So this entire infrastructure will go waste. There are resources to be extracted, nitrogen, phosphorus, lot of technology scale up is needed. Pathogens and pathogens removal. If you want to recycle water for higher ends, there's a question of reliability, because we have to develop a system which is reliable. If there are risks posed by the treated wastewater, so whenever somebody asks me why you say that costs are higher, because I'm imagining a very reliable system. Because if you say we'll provide you recycled water to industry, you have to provide. You cannot say tomorrow, okay, today my plant is not running, or today this particular parameter is not working. So that reliability cost also need to be incorporated in the system. That's why the cost of recycling water has to be properly counted. Emerging contaminants, we are already not able to match the carbon, BOD, nitrogen, phosphorus limit, and already so much use of household chemicals. And that's why I said consumer awareness. So many chemicals are used unnecessarily in the households and getting discharged, and that is posing another challenge to the recycling of water. Revenue models, who will fund this capital infrastructure and operation maintenance? That is a big question. Operation and maintenance, capacity with the urban local body, skill manpower, governance, and conservation. So these all need to be thought of together to really imagine this particular system. So we have basically, I have documented this entire story in this particular paper. You can read here, or write to me. I will send a copy. So basically what we are saying is, we have this particular urban water cycle where water treatment plant, urban area wastewater treatment plant is there. And currently we are doing it in a linear way, that we are disposing of the water and the nutrient. We have to go for this implementing these 6 R's, how we can change this picture from going the next city. So one city passing on the problem to another city, how we can fix this is the entire effort that we need to pose. So basically what we are, first we have defined what is recycle, use, and those definitions needs to be clear. So reduce, everyone at every phase, we have to reduce the water wastage and consumption. Reuse, cascading of the resources. So without treatment, how much water we can use. Recycle, city using its own water for the secondary purposes after treatment is recycle. reclaim city selling water to industry or industry buying water from city or some other stakeholders is a reclamation. Restore when there is no enough buyers. In many projects I have seen the good treated water is available, but there are no enough buyers. There is a policy gap. So you can again recharge the groundwater and recover. So energy recovery, nutrient recovery is the next phase of technologies that we need to adapt. So basically, circular economy provides you this kind of particularly very nice uh, framework for the bureaucrats and the managers, because here you apply system thinking, volume optimization, innovation, collaboration, stewardship, and transparency. We have identified how urban local bodies can work with industry and do this particular mapping of each of their uh, R's with these particular principles of circular economy. You can go through this particular detail, very thoughtful. My PhD students have, and I have worked on and given this particular tabular formulation. So how we can apply system thinkings, value optimization, innovation, collaboration, and stewardship and transparency. So that is the framework we have proposed. So what an entire point I'm trying to make is that cities first need to create a market for recycled water, because if there is no market, there is no point in putting so much of infrastructure. Only there will be regulation, but by meeting a regulation, if you can sell, the sustenance of the system will be improved. For example, let us discuss the Mumbai's case, where city of Mumbai, as if you all know, it is a coastal city, it's an island city, and these particular locations 1, 2, 3, 4, 5, 6. So there are 7 locations which are the draining point of the city, and this sewage flow is given here. So now city's planning, current plan is that they want to go for sewage treatment and recycling, because there is now this NGT order. So to achieve the high effluent water quality standards, the MCGM plans to spend around 20,000 crores of its on its 7 sewage treatment plant. So if you make such investment, it also demands that you must follow with efforts to utilize the huge volume of recycled water. So you can imagine 20,000 going in just for treatment is not a complete utilization. Why recycling is not possible in current context? Because it is not known who will consume the treated sewage unless there is a market for it. Cost of recycled water is around 10 to 12. It is not accounting the distribution cost. It is just the treatment cost I'm talking about. Whereas the freshwater tariff is about 3 to 6 meter cube 3 to 6 per meter cube. So there is a significant variation at a regional level. So although the MCGM has a telescopic billing policy, but the connections are not mapped. Most of the meters are dysfunctional. So the implementation of telescopic billing policy remains on paper only. So the production cost of water in Mumbai is about ₹15. So it's the issue of the price. At what price we are producing the fresh water? The revenue of the demand and collection from the MCGM is same for last entire decade. Okay, so basically there is no change in the raising the bills. That is the scenario currently. So this shows that the gap between production cost and revenue remains unbreached. And the MCGM, even in the DPRs, it is written, the plan is to have 25 to 50% of recycling at each recycling station. Let's say even the 10% realistically we plan, it is about 400 mld. The big question is who will be ready to use it, who will distribute it. It's a big question. The next issue is the location. The planned recycling stations are highly centralized at the fag end of the system in the near coastal areas. It will need a large secondary distribution network in mostly concretized roads already crammed with dozens of the other utilities. So instead, decentralized recycling station of about 50 mld. Now this 50 mld is my number, means you can debate about it, but for city like Mumbai, 50 mld also can be called as decentralized, and maybe more feasible in Mumbai case, as this will create an opportunity for establishing localized recycling network. And this, as I said, this number has to be decided for each city. For 100 mld kind of sewage flow in a city like Kolhapur, the decentralized scale will be different. So buildings can then have a second water connection from such localized recycling water, and modification in the storage and internal distribution. So there are a lot of changes in the consumers infrastructure are needed. The guidelines and bylaws, because the existing bylaws do not anticipate other water resources for non-potable use. That needs drastic change. So it's not the technology, it's not the physical infrastructure. So bylaws need to change to enable mandatory dual plumbing system for future buildings. I know it is difficult for existing building, but if we do not act now, it will be too much late. Again, 10 years I'll be making the same presentation that there is need for dual plumbing system. There is no point. So resizing of all the municipal connections, because current connection sizes are huge in Mumbai, at least we know. So residential, commercial, industrial established to restrict potable water supply for domestic purpose only, because they are getting a benefit of fresh water. When if you change the connection sizes, or you cut off the connections, some stringent action has to be taken. And mandatory uses for efficient water fixtures, and if possible a rebate, associated rebate, and minimum physical losses in the distribution system. That is another story how we can improve water supply. So creation of a recycling market will happen when the urban local bodies will work and talk to institutions, commercial establishment, industries, railways, metro boards, port trust. Small soil treatment system need to be created by working with these stakeholders, and we need some enablers. And I'll be happy to collaborate with whoever to work on this idea. And there is a need to provide comprehensive procedures and guidelines, responsibility of each stakeholder, who will sell, who will buy, at what cost, the level of treatment required, its use after treatment, expenditure, all this needs to be defined before we jump for a very fancy high-end recycling stations. So in summary, there is no immediate need for toilet to tap. Many people go abroad, see that, okay, everything is connected to, that is fine. In Western countries, we have, I told, the reliability, the guidelines and everything is there. So enough other avenues are available in India for other secondary purpose. We have to first create a practice of recycling of water. Recycling at the point of use or sale, that is the key. That if you recycle at some moon on Mars, who will distribute that water? So that is another challenge. So it is necessary to change existing guidelines and bylaws. Scale of implementation of the solution is important than the solution itself. Many people spend time on technology discussions, but what is the scale you are implementing? That is more important. A recycling water market need to be created in hand with recycling station, because unless you have a market, there is no financial sustainability for these recycling stations. Decentralization and closing the water, carbon, nitrogen, phosphorus and energy loops is the key to achieve the sustainable infrastructure. So I think that's all what I wanted to share from my side as far as my understanding about this topic, and I'm really happy to be here with this particular group of esteemed members. Thank you.